Alright, we got a pretty early video this week because the assignment came out ages ago, so yeah, we can start. The topics for this week, if you're watching this before the week starts, this is what we're doing. It's incredibly easy, so don't worry about it. We're getting our new learning pack as well at some point. I'm not sure when we'll get that, but we'll probably get a paper copy. From what happened last time is that we got a paper copy before it was uploaded onto SharePoint, so but the next learning pack is going to be the last learning pack, and it's also going to be the hardest learning pack. So get ready for that. But anyway, yeah, the topics are really easy this week. It's just correlation, and it's not hard at all. And then we have some consolidation after, from what I know about what we're doing. And for the assignment, we'll get into it in a minute, but it's a pretty difficult assignment this time. They included all of the some of the newer topics, and also included some harder questions, definitely. So don't worry if you struggled a bit this time. So let's get this up. So we're going to start off. We got some just normal integration, so it starts off decently easy, but so we just first finding the coordinates in section, you just set them equal to each other and then solve. You get substitute them back in to get the remember, you always use the easier equation to substitute back in. Remember that from GCSE. Then for finding the area, what I did here is I said that I'll just take away the area of this trapezium here from the area under the curve. So I did the trapezium, and then you take away the integral from that. You don't have to. What you also could have done, you could have done the integral of the line minus the integral of the curve. But it's easier, in my opinion, to just find the area like with coordinate geometry and then just putting it into one big integral. And it makes a lot more sense as well. So yeah, you just evaluate the integral. It's not like any of the new integral stuff we've been doing, so it's just normal stuff, and then you get your answer. All right, they've been loving these questions recently, where they just give you something in the compound angle form and then tell you to express it as a single thing. So the first one is just sine A plus B. The second one is sine A minus B. This one, you remember the way that you remember the tan one is that it's sine over cos. So it's plus over. So when it's positive, it's plus over minus. When it's negative, it's minus over plus. So here you take them away because it's minus over plus. For this one, it's just the normal sine one, so you add them. And then for this one, it's plus and minus, so you add them. Next question, we have some more trick stuff. This is a bit of an interesting question. So here I multiplied both sides by sec squared. Oh no, sorry. No, this is just an interesting form. They just cot tan is just 1, and something over sec squared is just cos squared. So it's just the reciprocal of cos, so it's just cos squared. And then the 3 cos stays the same. I just put the 2 over, and then it just does. Initially I divided by something, but it automatically goes into the form that you want it. So remember, if you're solving on your calculator, always use write out the quadratic formula, even if you're not using it. And then you know the range of cos is -1 to 1, so if it's outside of that range, then you can just cross it out, and then those are your 2 solutions. I remember it's in radians, so just remember to leave your calculator in the right mode. I tried doing some fancy stuff for this, but it didn't really work out. All you really have to do is just expand everything. So yeah, just the cos theta stays the same, then expand this one, and then I just rearrange the terms a little bit, and then the terms will cancel out. Because this becomes cos theta minus cos theta, and then these 2 sine terms will cancel out. Because sine 2 pi over 3 and sine 4 pi over 3 are just the negative of each other, so they'll cancel when it makes 0. Now this question was very interesting, because usually when you see something like this, you would try and divide, put all terms onto one side, but what you actually had to do here, you literally just had to expand everything out, and then when you expanded and then rearranged, you could just get them both into their compound angle form, and then divide, and that's your answer. So if you didn't really see that, then this question could really mislead you quite easily. Anyway, next question. This was an interesting one. So just sketch the graph and then sketch these lines here. And the way that you do this is you say that for finding A and B, you know the gradient of the 2 lines are -3, so you know the gradient is -3, then you differentiate, and you set the derivative equal to -3 because the gradient is -3 of the line, then whenever you're solving equations with a variable on the denominator, always multiply by the square of the denominator. So you do this, and then you get your two solutions. X equals 0 is a fake solution, and that's your answer. I don't think multiplying by the square actually did anything here, but usually, like, you should always do it because, like, 90% of the time, you do have to do it. And those are your coordinates. What else did I? Oh yeah, you had to find so I just found both the coordinates of the where the gradient was -3, and then put it into like y minus y1 equals mx minus x1, and then those are your answers. Alright, this is a very annoying question because it didn't really tell you much. Because it's just optimization, obviously, but the information they gave you is pretty misleading. So you had to say that these two are y, and then this horizontal one is x, not this one. So 3xy plus 2x squared, so not 4xy because there's not a top. There's no top here. And all that equals 54 because the surface area is 54. And then after that, it's just normal optimization. You rearrange for that. I rearranged for xy actually because I knew the volume was going to be x squared y, so it's easier to just substitute that in. And then you just substitute, get your formula. And then for part B, it's just differentiate, solve, blah, blah, blah. And then substitute. Because it's asking you the maximum for V, you just substitute it back in. And that's your answer. Next question. First, you just complete the square on both of these. Find center and radius. Easy stuff. Then it's asking you to say that, so it crosses the x-axis, which means that y is 0, so you just get rid of the y, and it would just become 4 squared, and then you solve the quadratic, and it becomes pretty easy. And you say that it's the length AB is just the distance between both the roots, which is just, because the midpoint of the roots is 6, and it's just 2 root 5 are like in the right direction, and 2 root 5 in the left direction, so it's just both those 2 root 5s added together. That's the distance in between the two roots. So it's just 4 root 5. Next, for part B, I had so many different ways of doing this until I figured out how to actually do it. So in the end, you know that it's a line passing through this point and it has gradient 2, so you can just put this into y equals mx plus c. You get the line, and then you can substitute y equals 2x minus 1 into this. Eventually you'll get a quadratic with x's and k's, and then you can use the discriminant and find k eventually after a lot of algebra. Right, we got some of our new differentiation stuff here. So firstly, you differentiate and factorize. You know that the range of e to the x is f of x is greater than 0, so this won't give you anything. And so you just divide by e to the 2x, and that will give you your two solutions. You solve this, you just take away 2x from both sides, and then divide. I think this is supposed to be a 2x, not a x. Oh my god, not an x. And then you solve that trig equation, and then substitute it back into the original graph. And then finding the double derivative, you just use product rule again. Sorry, I didn't mention this is product rule. This is product rule, and then you do product rule again, and factorize again, just to prove that. And then it asks you to find which one to turn maximum minimum. So this is just the old differentiation stuff. Substitute your value into double derivative, and you get your stuff. So next we got some more trig, and also some differentiation, I think. Oh yeah, just implicit differentiation with trig. So remember, when you're differentiating y, you just differentiate it normally and then slap a dy by dx on the end, and then you apply d dx to both sides. You should show that you're applying d over dx to both sides, but I was just lazy. And then you rearrange, and then eventually you get what it's asking. Next, I just didn't do part. I'm sorry. All you have to do there is just substitute pi over 3 in, and then use that as your gradient. You do y equals mx plus c, and that's your answer. Sorry, I don't know why I just didn't do that question. This curve has the equation, find the coordinates where the tangent is parallel to the x-axis. Did I just completely skip the rest of the question? I did. All right. I'm sorry about that one, because this actually looks like an interesting question. What you do here, you would differentiate implicitly, rearrange the dy by dx, and then just set dy by dx to 0. I think parallel to the x-axis means that the gradient 0. So you set dy by dx to 0 and then solve for x and y. Sorry, and then you might have to like solve a simultaneous equation with that. Actually, I think you will. So that's actually quite a long question. Sorry, I don't know why I missed it out. Because you'll probably get something like y, when you substitute dy by dx as 0, you'll probably get something like y equals 2x, and then you have to substitute that back into the equation and then solve. But yeah, sorry about that. I don't know what I'm doing. Find these. Right, so now we're actually on a question that's done. These are pretty easy. You just turn 1 into ln e and then take away the ln, solve. Just ln both sides for this one, solve. This is a hidden quadratic, so you just factorize and solve. This one you can just add. Don't make the mistake that I made and multiply the powers initially. Just add the powers, ln, and that's your answer. And that's a pretty easy question. Next question. So we have find the equation of the normal to the circle. So first you differentiate implicitly. So like make dy by dx a subject and simplify. Then you can substitute this in, and then remember you do the negative reciprocal for the normal. Find your line, and then that's your answer. Find the coordinates of the second point, and the normal cuts the circle. Well, that just means it's just simultaneous equations with circles, which is not fun, but it's just you have to do it. Just a lot of algebra again. Substitute the 8 minus 2y into all the x's because you just got this line here. Yeah. Right, these proofs are interesting because they will usually, if they come up, they'll be like very hard questions. They'll be like 4 or 5 marks because this stuff will be in next year's content. Not the e to the y thing, but these three are in next year's content, doing like derivatives and integrals with inverse trig, except you have to apply it a lot more. But for this year, all you really have to know is the proofs for it, and they will always give you this, because in second year they won't, but in first year they'll always give you this. They won't say prove that d over dx arc sine equals that. They'll say given that x equals sine y, show that dy by dx equals this. They won't tell you to find the derivative of arc sine. But for these, you just do implicit differentiation. So for part A, differentiate, rearrange, and then it always involves some sort of substituting your answer back in. So here it's 1 over e to the y, but e to the y we already defined earlier as x, so you can just substitute that in. Next one, you differentiate implicitly again, and this time you turn cos y into root 1 minus sine squared y, so that you can substitute it back in. And then same with this one, you do the exact same thing, except it's negative, because you're differentiating cos, not sine, so that turns into negative sine y. And then for tan, you can just turn it into sec squared, and that will turn into 1 plus tan squared, and then substitute that back in. Right. I think this is the only proof question on the entire thing. So you just define you can use a lot of fancy notation, but I don't think you really need to. So I just said, let these numbers exist. And this, I'm guessing when they said positive integers, I think they meant not 0, because there is a case where one of them is 0. It does work. So I'm just assuming that they're natural numbers, which means positive integers, not including 0. Then you write out the equation they asked you to. And then here is just a classic case of difference of 2 squares. And then here you just say that there's no 2 integers that multiply to make 1 negative. In this scenario, there's no 2 integers that can multiply to make negative 1, except 1 and negative 1. But for that to be the case, one of them would have to be 0. Or no, x would have to be 0, but that's not in the set of n, so of big N, which means that there's no possible way that this can exist, which means there's a contradiction. All right, this was a bit of a joke question that they gave us. I mean, I like what they were doing, but I also don't because it was annoying. So this first part's easy. It's just chain rule. I just remember that sine squared is sine 2x. You don't really have to, but anyway. Next question. So the integral is kind of the annoying one because so whenever you just have, obviously the first one's easy. It's just cos x negative cos x plus c, and then for the second one, I honestly just remember the half angle formulas, which is sine squared equals half minus half cos 2x. And yeah, but for when you have odd powers of sine, or cos, honestly, but when you have odd powers, you turn them into half minus half. You do the half angle formulas, and then um, yeah, when you sorry, no. When you have odd powers, you use the Pythagorean identity. So I turned it into 1 minus cos squared. I turned the sine squared into 1 minus cos squared, and it leaves one sine left because we've gone from sine cubed, we've taken away sine squared, and we're back to sine now. So it's just sine x brackets 1 minus cos squared x. You expand, and then now you have, this is easy, and then this is reverse chain rule, the second one. So you can GDA it if you want. Then for even powers of sine, which is what I was trying to say, you turn them into the half angle formulae. And then here you get another you have cos squared 2x, you turn that into another half angle formulae, so you get cos of 4x. And then after doing all this rearranging, you can integrate it just using your normal trig function stuff. Just remember to divide by the number here because of reverse chain rule. And then, yeah. Did I not do? Oh my god! Did I not do sine to the 5x? I didn't do sine to the 4. Great. So what am I going to do here? I think sine to the 5x isn't that bad. You just have to do you have to turn two of them into 1 minus cos squared. I think. Yeah, you just turn two of them into 1 minus cos squared, and then there'll be a sine, so that means you can use reverse chain rule on all of the causes, and then they'll integrate pretty nicely. Anyway, sorry about that again. Hopefully I'll remember to do more the actual questions. Alright, these first principle questions are hard, so these would be like 7 marks in the exam, probably something like that. So I only did a proper proof for this first one, the other ones were kind of lazy. So you write f dash of x twice, write the formula, always remember to put the limit down. So for this one, my strategy whenever I'm doing stuff like these 3 first principles, you multiply by whatever function you have, you multiply by, so for sec this example, you multiply both sides of the fraction by sec x plus h multiplied by sec x, and you get this. Sorry, you multiply by the inverse of that. So for this one, I multiply both sides of the fraction by cos x plus h, and then it turns into this. So we just kind of, you can do that in your head. So when you have sec x plus h, cos x plus h just turns into 1, and then the cos x stays. And then for this one, sec x cos x cancels out, and then you get just cos x plus h. And then the bottom nothing cancels on the bottom. And then now after this, it becomes a lot easier because you can just expand the x plus h. Then separate the fraction, because always your goal with these ones is to end up with these 2 standard results. So sine theta over theta as theta approaches 0 is 1, and cos theta minus 1 over theta when theta approaches 0 is 0, which you will not have to prove in the exam. You won't have to prove these results in the exam. So you always just want to end up with this. So so you do this, you can take the fractions away. I saw an opportunity to, in this one, you can cancel out cos x and then factorize 1 minus cos h over h, which just turns into negative 0, which is just 0. And then this one, you can factorize sine h over h out of it. And then this one entirely cancels out because we have this one here that turns into 0. And then the sine h over h cancels on this one. And then for this one, you have to say it looks like a bad fraction, but actually this entire bit of the denominator will fully cancel as h approaches 0. And as h approaches 0, cos h will approach 1. And that means that the cos h will just go away. This entire bit of the denominator will go away, and you just end up with sine x over cos squared x, which is sec x tan x, which is what you need. Yeah, pretty long proof. But basically, just to summarize it, you multiply by the x plus h and the x of the inverse of the function that you're doing. Then try and just find the standard result somewhere, so sine h over h, cos h minus 1 over h, and then at that point it will turn into something that you need. For this one is practically the same. Instead of multiplying by cos x plus h, I should multiply by sine x plus h because it's cosec. And then I did the exact same thing. It's really not that interesting. The only difference, you just have to remember the negative here because remember that anything when you differentiate it is negative. And then for cot, it was actually an interesting one here. So I was going to multiply by tan, which probably would have worked. But then I tried with sine, cos, and tan. And with sine, what happens is that it turns into this. And the thing with this is that it turns in sine x cos x plus h minus cos x sine x plus h. You might recognize from one of the previous questions is the compound angle formulae. So that will just turn into sine of x minus x plus h. Or x minus brackets x plus h, which just turns into sine of minus h. And we don't actually know this yet, but because sine is an even function, you can just factorize the h out of here. Or not factorize, you can take the negative out of the inside. So it just, sine of negative h is the same as negative sine h. Which is something you should just be able to kind of figure out if you just think about the graph. And then after that you can factorize sine h over h out, and that will turn into what you want. Literally instantly, it will turn into what you want, because this will cancel out just like in the previous ones where the denominator fully cancels. Or part of the denominator cancels, and it will just turn into cosec squared, which is what you want, or negative cosec squared. There's probably a few ways you could do these. I do not blame you for looking this up either, because these are very hard, and these would be like, if these came up on the A-level paper, they would be by far the hardest question on the paper. It would probably be like rivaling one of the hardest questions that's ever come up on an A-level paper if this actually came up on an A-level paper, because the algebra for this that you have to do is ridiculous. This is why I just remember what to do. Like, if I would have no idea if I didn't remember what to do here. Right, part B, thank God there's a bit more applied stuff here, because there was a lot of hard pure stuff on section A. For this one, you have this model here, this quadratic model, linear model, and this just literally models the balls thing and the ceiling. So you can just set them equal to each other, and if they hit each other, then they will hit. So set them equal to each other, do this, and then you say that if there is no solutions, then they won't collide. So you're like assuming it's kind of like a hypothesis test, which we'll be looking at later. So if it doesn't hit, if there is no solutions, then they won't hit, because if it equals 0 or it's greater than 0, then it will hit. But if it's less than 0, then it definitely won't. So that's why I just did this, and then I proved that b squared minus 4az isn't less than 0, therefore it will hit. Next one, we have this interesting question. Ignore this diagram, it's completely useless. It's just saying that a force of 60 newtons is needed, which means the max force is 60 newtons. That's like the max of limiting equilibrium, which means that what have I done here? Oh yeah, the max force is mu r. So F max is this, and we know that F max equals mu r. So we just get 60 equals mu times 15g, and then you can solve for mu. Next question. The force needed to give an acceleration of that, where you just, I drew an actual diagram here. So we're moving it, we're looking for x, and we need it to move that amount, which means that you would just do F equals ma. The resultant force is just F minus 60, so F being x here, I just changed the variables around. So it's just x minus 60 equals ma, which is 15 times the acceleration that we need. And that'll give you your answer. Right, already getting a bit, voice is already suffering, and we're on question 3 of section B. So this is easy, you just take away everything from 1. get the intersection point, and then this is just independent event checking. So when you multiply the events, that's the intersection. You just say that it's not independent because they don't equal each other. So next, this is for if you're watching this before the week that we're doing it. It's before the tracking test, so this is good revision for it. I don't know why you'd be watching it before, because the assignment's due the next week after the tracking test week, but anyway. So first we're finding the bearing. So you just have to remember the bearing from GCSE, that bearings are always to the north. And also, I don't think they really care about this in A-level, just judging by the mark schemes, but you need to remember to put it's always in 3 digits, the bearings. But for this you just do arctan of the j vector divided by the I vector. And you just take it away from 90, since I just drew the diagram here and realised that you need to take away 90 for it to work. So next for B, we need to find the position vector of P at any time and the position vector of Q at any time. So you just write out, use R equals R0 plus VT. Then for part 3, PQ, you just do Q minus P, and then that will give you your answer. Then for part C, when Q is due north of P, it means the position, not the velocity, the position of Q and the position of P both have the same J component, which means you can just have both these equations and then solve simultaneously. And then you remember it's T hours after 2 p.m. You have to remember that. Then for this was weird because it's not asking you. It's not, so with north you can just say that they're both fully of the same thing, but when it's Q is northwest of P and not the origin, you have to. What I initially did is I said that I did the same thing here, except I used IJ for this one, and then I plus X, J plus X, because they both have the same. They're both, Q is the same I and J component away from P, but actually I realized that you can just set the PQ ones equal to each other. That's all you have to do. You have to set the I and J components for PQ equal to each other, and that literally just gives you your answer, because you know that PQ, the I and J components of P to Q is the same, so you can just set them equal to each other and then solve, which is a much easier way to do it than I just described. Alright, projectiles is a pretty decent. This is an okay projectiles question, but I can if it's fine if you forgot, because we haven't done projectiles in a long while. So I'm just checking my mic. Yeah, it's fine. So you always remember, you write down the SUVAT for the vertical and the horizontal. Do S equals UT plus half AT squared for both of them, and then substitute T in to get rid of T, and then eventually it will come together. This one actually didn't ask for G in your answer, which is interesting, and probably because it just simplifies to 90. And then for this one, you just substitute X and Y. Just remember that when you're solving an equation like this, you can turn something over cos squared to sec squared, which you can turn into 1 plus tan squared. And then after that it becomes pretty trivial. It's just remembering this identity here. Otherwise you might just play around with this cos squared for a while. And then you get your answer. And you're not finding alpha, you're just finding tan alpha, so you don't have to worry about solving. Alright, so now we have another vectors and mechanics question. So we're finding the distance of the boat we're finding the distance, which means it's the magnitude, which means you just do the magnitude of the vector in between them. Now the bearing, I drew the entire bearing down here accurately, because I realized that I need to do 360 minus 90 minus the bearing from here. That you just kind of look at the diagram and you realize what angle you need. Because what I found is this angle from BA to this horizontal, so I need to do 90 minus to get this, and then 360 minus the entire thing to get the bearing that you wanted. Also remember to always round to the nearest degree when you're doing bearings as well. That's another thing you need to remember. Verify that the boat is traveling directly towards the buoy. That just means they will collide at some point, which means when you set them equal to each other, the equations will be homogeneous, which just means that they do hit each other. They do hit each other at the same point. So for this equation, so I set them equal to each other, and resolved both the I and the j component and found that t equals the same value, which means that the equations do work together, which means they will hit each other, which means that they are traveling to each other. Next, part D, we find the speed of the boat. Well, that just means the magnitude of the velocity. I didn't write the unit here, actually. I probably should have. Work out how long it would take the boat to reach the buoy. Oh, here, because I already found it here. So, because there was probably an easier way to do this one. So, other than finding the time. So, but for this, I just found the time, so I can just write the answer here because I already found it. Oh, God. All right, so these questions, there was an unhealthy amount of stats in this last bit, especially these two questions. I hated them. So, when you're doing these histogram questions, you have to look at the class width is the length. Remember, the class width is the length, frequency density is the height, and then you find the scale factor between them. So you find, so for this bar here, the class width is 10. I don't know, this is the thing I was most confused about, because I don't really understand why the class width is 10 and not 9.5, but it is 10 for some reason. And the height is 13 over 10, because you want the frequency density and the class width to both multiply to the frequency, so that's how histogram works. And then I drew out the box, and you say that 1.3 times scale factor, the height scale factor is 2.6, and 10 times the length scale factor is 2.5. You find those scale factors, and then you can apply them to the other classes that you need. Yeah, and that's what you really have to do. So when you have the scale factors, it's not that bad, because all you need to do now is just find the frequency densities of the classes and then apply the scale factors. Now for part B, they made us do the entire thing again. So again, find the class width, find the frequency density, do both the scale factors for the length and the height, because they're both different. They should be pretty decent numbers. They should, because for the first 5 times I did it, I got long decimals, so that was not very fun. And then you apply the scale factors to the bar that you want, and those are your answers. Next, we have some more stats. The first part isn't that bad. You just do some interpolation. Not very interesting, but just do some interpolation here. Not really going to explain it. For part B, you just so it's the same thing as last time. So we're finding the dimensions of the bar. Oh, sorry, no, this is part B. So you find the class width. This is the same as the exact same thing that we did in the last question. So class width of 2, frequency you find the frequency density by dividing them, and find the length scale factor, the height scale factor, and apply them to what we need in both parts. Right, no more stats. Well, there are some still stats, but it's not histogram, so I'm not mad. Now, I wasn't here for these lessons, so I didn't really know what was going on that much. But this diagram's pretty inaccurate because they're not at the same height. A is in a different height to B initially. But firstly, you just draw a decent diagram with all the forces. So firstly, is actually they put suvat later in the question when they're doing force questions, but here it was just instantly. So you know the distance is 2.5 because it says in the question. You know the initial velocity is 0 because it starts from rest, and then the time is 1.25, which it says here, and then you can just use this to find it. Then finding the tension in the string, here you in both these questions they wanted you to use the fact that the tension in the string and the masses of the the tension in the string is the same. There was another question where they wanted you to use it, but in this question, in the first question, in part A and part B, they wanted you to say that they asked you. So for part A, you had to find the acceleration of B, but your calculations made you find the acceleration of A, and you have to say that the acceleration of A is the same as the acceleration of B. Same with this one. It asked you to find the tension in the string A, but it's impossible to find the tension in A. You have to resolve B to find the tension, which is just the same as the tension in A. So here you resolve B by saying the resultant force. I'm just assuming that B moves upwards. It doesn't say in the question, but it does say that A moves down and hits the ground, so you can assume that B moves up, which means that the resultant force is T minus 3G, so tension pulling up minus the weight pulling down equals MA, and then that gives you your answer. For part C, just resolve in this one, and you get your answer, not too complicated. And then using that's inextensible, which means that tension is constant, then these questions are very long. These are usually like 7 marks again. And so there's this new information here that A strikes the ground and doesn't rebound, string becomes slack, and then B moves freely under gravity. So firstly, you just find the final velocity of A, which, because this is the thing you should always remember for these types of questions, you find the final velocity of the one that we're not looking at, which becomes the initial velocity of the new one. So we found the final velocity is 4, because we have literally every piece of information except the final velocity for A. So then we have this new we set up this new suva. I drew the path of motion for B, because when it stops, B will get carried upward by the momentum and then go back down because there's nothing on it anymore. And then we say that we find the time that it takes to get to the top, which is what the hell? Oh, 4 over g. And basically the idea here is we're finding the time from when A strikes the ground to when it becomes taut again. So I'm just adding the time that it takes to get to its peak from the time that it takes to go back down. So, and we know that when it hits the ground, it will be at the same level that it was initially. So we know that the distance is going to be, what's his name? Where have I found 0.8 from? What have I done? I said the distance is 0.8. I'm guessing I found the distance from here. No, I didn't find the distance from there. Alright, I found... Sorry, I don't know what I've done here. Alright, I think what I've done here is I found the distance with this suvat here, and I just said it goes down the same amount. So now, so we've already found the time, the distance from here up to here, and now we're modelling the ball. It's starting from here, which means the initial velocity is 0, because we're only looking at vertical velocity, and acceleration is just positive g now because it's moving down. And then we said that the distance from when from when A will go taut again to here is 0.8, and then you just solve for t, and then you can add both. So we have this time that it takes to go from the initial point where A hit the ground to the peak, and then from the peak to when the string goes taut again. So you just add those 2 times together, and then that gives you your answer. Jesus, that was a horrible question. Sorry about that. Next, so this is some of the core pure stuff, so you don't have to worry about this right now. It shouldn't be too hard, but if you don't guess it, don't worry, because it's next year's content. So I don't really know where they're putting it in our assignments, to be honest, because it's next year's content. So, but when you're finding points of intersections, you just set them equal to each other and then resolve the components and then substitute. You don't actually have to find both of them. You only have to find one of them of the scale factor of the scalars, and then you just substitute that scalar into its respective line, and that gives you the point of intersection. So here you just set them equal to each other, compare coefficient. No, just you like resolve. Sorry, you equate the vectors. Sorry, you do like 4 minus lambda equals 5 plus 2 mu. And then solve the simultaneous equations, get one of the scalars, substitute it back in. Same with C, like resolve, and I don't know what the word is. I think it's equate. So you equate the coefficients of both the vectors, and then blah blah blah, and then substitute it back in. Boom. So next we've got some binomial distribution stuff here. The conditions that need to be true for a binomial model to be valid, so independent events, 2 outcomes, and it also needs to be a fixed probability of success. That's another one that could be. So firstly, we've set out the distribution, and we're just finding p of x equals 1. Then you find x is greater than or equal to 1, which says at least 1. Then for this one, it's asking you to set up a new distribution because we have an unknown number of trials. And it says that a 5% chance that his new sample will contain fossils, which just mean it will be, it will be 1 or more fossils. Which means we're just finding the probability that this random variable is greater than or equal to 1, which would be very hard to do without a calculator, because we can't do this with the calculator since we have a variable as one of the parameters for the distribution. So you just do 1 minus the probability that x is 0, and that makes it a lot easier. So you just rearrange from that, and then you use the binomial formula, which is n choose x times p to the x times 1 minus p to the n minus x, I think it is. But here you know that n choose 0 is just 1, so you can cancel that, and then you know that x is 0, so that you can just cancel the other one out, because anything to the power of 0 is 1. So it's just going to be 1 minus 0.1 to the n minus 0, which is just 0. But if you don't understand what I'm saying, you can just look at the formula book, because it is in the formula book, and do it yourself. You can do like all the you can write out the entire formula and cancel everything out manually, but I just went from here to here because I know that everything before that is going to cancel. And then you just do the log, take the ceiling, which just means the rounded up version of that, because we're looking at the number of a fixed number of trials. You can't have a decimal number of trials, so you have to just round up, and then that'll give you your answer. Next, unfortunately, this is our first assignment where we have a hypothesis test on the assignment. So just remember, so define your variable, define your hypotheses, define your distribution. For now, we only have binomial hypothesis testing, but we will, well, if you're watching this, like shortly before the assignment's due, we would have also done correlation hypothesis testing, and then we also have normal hypothesis testing, which we'll do later on. And then you have like 10 more hypothesis tests if you take further stats. But anyway, let's set up your distribution, and then here you should always do p-value if you can, because it's quicker. So just do the p-value, say that it's greater than the significance level, and then you do your paragraph about why the hypothesis sucks. Yeah. And that's it. Now, this question is a paragraph. You get a literal paragraph before this question, because it's just a bunch of exam like words. So, but all you really have to do here, you do your connected particle stuff, so with the tensions and the masses and the etc. I should have drawn the A here as well and the A here, but I was just lazy. Then you do the tensions for the inclined plane, resolve all your forces for the inclined plane, put your mu on, your R down, and then now you can put everything on your cross diagram, or however you want to do it. You just resolve parallel and perpendicular to the plane, and then you can find the tension in this. So you resolve B, and then you resolve A. You resolve A parallel, because when you resolve perpendicular, you get your R value, and then when you resolve parallel, you get your equation of motion, and then for your other equation of motion, you just resolve B, and then solve simultaneously, and you get your answers. Next one, you remember that when you're doing the direction, the magnitude of the force exerted on the pulley by the string, it's just 2t cos theta over 2. But firstly, you need to find theta. So it gives you as a trig rate. I couldn't find a way to keep it as an exact value, so I just did 90 minus, because you know this is a right angle triangle here. So you find alpha by using this here, then do 90 minus that, which gives you this angle, and then you can do 2t cos theta over 2, and then that will give you your answer for the tension. It does say direction, but I think that's just, I don't even think that's on the mark scheme, so, or in the answers. Alright, almost there. I think this has been probably the longest video I've had, because it's a hard assignment. So we have this thing here, so, wait, what? Oh, sorry, we have part C now. Find the total distance A moves up the plane since the particle is released. It says after 2 seconds the string breaks, so we just do that, set the initial to 0, because they were like releasing the system when t equals 0, which means the initial velocity is going to be 0. You've already found the acceleration, which is 1.58, and then you know it's 2 seconds, so just do your that. You have whenever you have 3, it means you can find the other ones, so that's your answer. Alright, now we can get onto this. So this was supposed to just be tree diagrams, but you can think of it as for this first one, I just thought of a binomial distribution, which makes it a decent bit easier. Then for this one, it says in the 5th packet she opens, she gets a yellow aeroplane. Well, that's just the thing we found before multiplied by a quarter, because there's a quarter chance that happens. And then for this one, it's a 1/16 chance, and there's 12 different ways you can do it. And then for this one, there's a 102, the 1 over 4 to the power of 4 chance, and there's 12 different ways of doing it. And then that'll give you your answer. Wait, did I? I think I wrote down the wrong number here. I think there's more wait, sorry. I know there's 20. Sorry, what I've done this wrong. The answer's right, but it's supposed to be 24 times 1 over 256 because there's 24 different ways of doing this. I don't really know how to explain it because you can use the choose function to figure this out, but that's not something you necessarily have to know. But you kind of just have to think of it as a tree diagram, and then you can just figure out how many different like combinations you have. All right, we're at the last question. We can finally get to this. So when you have double brackets like this, you just expand them, and it will probably cancel. So here you have 2 tans that cancel, and then this fraction will turn into 1 minus sine squared over cos, which turns into cos squared over cos, which turns into cos. When it just gives you this gibberish here, it just basically means that tan x can't be tan 90, which is undefined. It basically just means that this has to be the case for this to exist. That's the only reason why this is like this. So you don't have to worry. So basically what I'm trying to say is you don't have to worry about these domains here when they give domains in trick questions. Unless it's like x is greater than 1 or something like that, and it actually affects the question, then don't worry about it. Next question. This is actually nothing to do with the previous question, because usually when they do questions like this, they use the previous question to make you substitute something in the next question. But and they will say hence or otherwise, but here it doesn't say hence, and it also doesn't say otherwise. So it's just telling you to solve this. I just turned sec squared into 1 plus tan squared, and then it doesn't even turn into quadratic. It just turns into an equation you can solve. Just remember the plus or minus, and then also remember to change the range from pi to 2 pi, and then that will give you your final answer or answers for this question. Alright, that was a long video. I'll see you next time. Hopefully we have some very interesting stuff in our next learning pack. Definitely the hardest half term, but after this half term we'll be done with our first year content, so that's good. I'll see you guys next week.